Just a quick video on the two searches, sequential and binary. Here we've got an array of strings, a little scanner asking who do you want to search for during this fire drill, bringing in a key. We usually call what we're looking for the key. And usually either the sequential search or the binary search will return an integer. The reason it returns an integer usually is that we are looking for an index, in the case of arrays, of an array. Because at that index, if it's an object, will not just be, for example, a name, but other things associated with that name. So we don't want to just know that Betty is there, but we want to know the other things associated with Betty at element number 0, 1, 2, element number 2 of this array. So it doesn't have to, but usually you'll find the sequential search or the binary search will return an int. Maybe the first thing to remember and take a look at is if it does not find what it's looking for in either one of the searches, they will return -1. So -1 is the indication when the method evaluates that the search item was not found. So if sequential search array key resolves to or evaluates to -1, then the way that I've done it here is if we go to the else and say that student is not accounted for, go back and look for them. But if that number returned is not -1, in other words, if this is true, we found in this case, student we were looking for, and this where not found, not being 1, will be whatever index who we're looking for is at. So we'll use that index, where not found, here in our output. Yes, the so-and-so, so Betty for example, is in the array of students present at element number, and that'll be what, 0, 1, 2 for Betty. So let's see how the sequential search works. It takes in 2 parameters. In other words, it is sent 2 arguments. It is sent an array of a certain type, and the sequential search works with an array of strings, and an individual key string that it is looking for. And starting at the 0th, at the very beginning of the array, and looking through to the end of the array, which will be 1 less than the length. In this case, 0, 1, 2, 3, 4, so the 4th element. It will say, excuse me, it will say if where we're at, array 0, then array 1, then array 2, then array 3, then array 4. If at any point that array element equals what we're looking for, Betty, I guess is the name that I'm using in the example, then we will return the I that is the I when we have found it. So if we were looking for Betty, we go through 0 and not found it, 1 and not found it, 2, it would have found that the array at element 2 does indeed equal Betty. So the 2 is what we would return, never getting to the returning of the -1. And yes, Betty was found at element number 2. And I suppose we can run this quite quickly. There you go. So now I'm going to switch out the sequential search for the binary search and not change anything up in my main menu. Excuse me, but we are sending the array and the key now to the binary search. Here it is. Takes in the array, takes in the string. We have a low and a high, which will be either end of the array. And I really can't, in this kind of a video, talk about, well, I can talk about it, I can't show you, that eventually if what we're looking for is not found, the high and the low will overlap. But while they don't overlap, while the low is way over here, so and the high is way over here, and we chop it in half and move the high and the low, but sooner or later it is possible that we will not find. If we look for the name Billy, Billy is not in this list. If we look for Billy, then sooner or later the high and the low will overlap, and that will not be true, and we will skip down to the end of the while and return -1. That's when what we're looking for is not there. But in the meantime, what we're looking for may be there, so we need to look to see if in the middle of the array what we are looking for is there. How do we get the middle of the array? It's high plus low divided by 2. As we start, 0 in this case plus 5 minus 1 will be 4, so 0 plus 4 divided by 2 will be 2. So the very first mid in this one will be, we found it right away if it's Betty. So with the mid, we say if what is at the mid of the array, the mid element of the array, equals the key, then we return the mid. So in the case of Betty, it is immediately. The very first time through the while loop, the mid, which is 2, is Betty. And so we return 2. So there you go, it would be 2. And if we were looking for something that was not right in the middle the very first time, if we were looking for Chisanga. Chisanga starts with a C, Betty starts with a B. So the question we ask is, if the key, Betty, compared to, the key, if we're looking for Chisanga now. So if we're looking for Chisanga, Chisanga is the key. Chisanga compared to array mid, which is Betty, is less than 0. Well, it won't be less than 0 because Chisanga with a C, if we compare it to Betty with a B, will actually return a number greater than 0. For that, you can look at the other video associated with this, which is the one where I talk about how we use compare to. But that's the other video that should be linked right next to this. So if Chisanga is greater than Betty, then this is false, and we skipped to this one where the low becomes mid plus 1. Looking for Chisanga, come in on Betty. Chisanga is not, the way that we've written it, less than Betty. It's not over here, so it's over here. So we change the low. The low used to be here. Now it's going to be shifted over to be right on Chisanga, actually, because it's a small array. So the low will have changed. Note that the high will not have changed. The high will remain over here. So our low is here now, our high is here now. We go through and we do it one more time, all these things, and I'll just talk them through. This will be the last time that I scroll down to there. So again, we looked at the mid. This wasn't it. It wasn't less than. What we're looking for was not less than Betty. It was greater than. So we shifted the low up here. So this is the low. This is the high. We go low plus high divided by 2. So 0, 1, 2, 3 plus 4 is 7 divided by 2 in terms of integer division is 3. So our mid is 0, 1, 2, 3. So low and mid are both Chisanga now. And we ask the question, is mid what we are? I guess we'll scroll just one more time. Is mid what we're looking for? If we're looking for Chisanga, yes, and we return mid. So let me just run that, and that will be it. And frankly, if you can follow this just with my voice and looking at the code, that's pretty good, because it's much easier to understand when you've got a diagram or somebody writing stuff on the board. But in terms of the quick verbal description, that's it.